Hey guys, Mr. Gardner here, and this week we're going to be talking about scatter plots. What scatter plots are a way of displaying data when we're talking about comparing two variables against each other that may not just have like a linear relationship um, like we've been looking at in the past, but we can use some of that information about trends, like whether things are moving positively or things are going negatively, or there's no real change. We can use that understanding when we're doing scatter plots. The thing with scatter plots is it's not always like a perfect set of data. Sometimes the data has little bits of skew in it, and so that's why we use a scatter plot to show it. So let's think about this example here where we have the amount of time in batting practice. How does that affect the player's batting average? So kind of like in science, we would think about making a hypothesis, and we might think that more time spent in batting practice should lead to a better batting average. So you could think about that if we were going to graph something like that, right? And maybe we're graphing data. So maybe we got a whole bunch of data. So let's show a bunch of data. Let's say data. And maybe we have different players and it's like, and then average. So, right. So this should be time batting. So time practicing. Okay, so that's going to be time practicing, and this is going to be their batting average here. So let's just think we have maybe a bunch of data. Let's say one guy spends an hour, another guy spends an hour, and another guy spends an hour. And from that data, we get like 239 as his batting average, 244, and 250 as our batting averages. So if we were to graph that, right, this would be maybe hours practice, and this would be average. So we could see maybe for 1 hour, and we'll make this like hundreds. So 200, 300, 400. And 400 really in baseball, if you have a 400 average, that's like exceptional. So let's just say like for one, we have a guy like here, here, and here. Now let's look at maybe for 2 hours. Let's say for 2 hours, somebody's at 266. And another guy at 2 hours is maybe 270. All right, so again, we could be, oh, that point's a little high. But again, we're a little bit up here and up here for these numbers. We can see 3 hours, maybe those points are like here and here. And 4 hours, maybe there's a guy here, but somebody here, here, and here. Right? And maybe at 5 hours, we have a guy more up here. And so we could see, right, if we look at that, then as we're looking at that data, we can see that it trends upwards. As the time we spend in the batting cage goes up, so does our average. So we could say that that has a positive correlation. And that's what we're going to be looking at really for the rest of the lesson is do these things relate positively? Do they relate negatively? Or is there really no relationship at all? So let's look at this set of data here. So again, we don't know what these two values are, but we can make assumptions as to what's going on by looking at the data and the trends. So let's just mark these down. Again, we always want to put X on the X-axis and Y on the Y-axis. So we'll just mark these so that we go all the way up. So here it should be like 1, 2, 3, 4, 5, 6, 7, 8. And then on this side, let's go by 5s. Let's go 5, 10, 15, 20, 25, 30, 35, 40. And then let's just graph what we see. So we have 2 is at 8, so that's going to be right around here. 3 is 13. So that's going to be between 10 and 15, so like there. 4 is at 15, so that's going to be right about here. 5 is at 21, so that's going to be up around here. 6 is 23, so a little bit higher. 7 is at 30. 8 is at 32, so it's a little bit higher. So again, when we were doing it before, we were like checking these things. So we can see that this is 5, and this is 1, and this is 2, and this is 1, and this is 6, and this is 1, and this is 2, and this is 1. So again, when we're looking at that, we definitely don't see any linear trends here. So this isn't telling us that we have a line, but we can see here it looks linear, right? It's just that the points are a little off of a line. But if you thought about it, then you could say, what about this data? Is this data positively related or is it negatively related? Like as this number goes up, is this also going up or is it going down? And I would say, looking at this, as this is going to the right, as it's moving this way, our data is also going upwards. So that would tell us that we have a positive correlation. Right? So like whatever this is, this may be hours driving and this is miles driven, right? It makes sense. As more hours you drive, the more miles you've driven. Has a positive correlation, right? Or it might be hours of study and test scores, right? If you study more, your test scores should go up. Okay, those should have positive correlations. All right, and so bivariate data is just simply data has two variables. We want to be able to determine their relationship between them, like amount exercising and an adult's weight. So you may survey 100 adults and graph the data. Both the time spent exercising and the person's weight are variables. This data would be considered bivariate data. And you can think about that, right? And we don't even have to graph this, and we don't have to ask the 100 people, but we can think about this. And you could think, would you expect that, and it's not always going to be true, but you would expect that people that work out a lot more might have lower weights, right? But it doesn't always be true. There's a lot of other factors that would be related in there. But we could see that might be trending positively. We could also see it the other way too, right? If we graphed it the other way, it might be less time spent working out leads to higher weights. And if we kind of held things the same, maybe all males or all females, and we did it the same height or whatever it may be, same age, but we should see some relationship. All right. So again, the data is used to show relationships of two factors. Sometimes it shows a lack of relationship. Sometimes they don't show anything at all, right? And so we can't get anything out of that data. But it's good to know that, right? So that you're not just saying things that don't really have justification. And so again, if we look at this data here, we're doing math test scores that hour studying. You can see it's not always true for everybody, but as a trend, if we were trying to fit a line in here that fit this data the best, we would see that as the hours increase, as we go this way on hours, our test scores are going up. And so we'd see that would be positive. That'd have a positive correlation. Now here you can see negative correlation, right? And this could be true as well, right? Is that here's math grades and here's absences. So few absences are higher math grades, but as your absences increase, going this way, we can see that your math grades actually going down, and that's a negative correlation. Oh yeah, what is this little guy? This guy kind of is way out here, right? Doesn't really fit our data. So what we call that is an outlier. Okay, outliers do not fit the trend. And that's okay, as long as there's not a bunch of points up here. If there's one or two up here, we just call them outliers, and we usually just disregard them. All right, because they're just like exceptions to the rule. It'd be the same here if you had somebody with no absences but had a really low grade. That would be an outlier as well. That would kind of fit this same mold of being an outlier. Okay, it doesn't really fit the data. Again, we talked about no correlation, right? You could say how tall you are in your math scores, right? It doesn't matter well, if you're 1 foot, you're really little. So it kind of should affect your math score. But you can see that there's no real correlation here. I can't fit a line in that fits this best because the line could go that way, could go this way, could go that way, could go straight. So really, you can't get anything from this data. It doesn't tell you anything. Height doesn't really affect your math score. So there's no correlation there. All right, and that would make sense. It's kind of like the size of your shoe and the type of car you drive. I mean, there's not going to be any data that correlates those two things. All right, another thing you get when you're doing these is sometimes there's a cluster, and a cluster is just a big grouping. So, I mean, if you're talking about this, you have like a big cluster of math formative scores. And so what you could say is between the hours of 4 and 6 hours of studying, you're going to get your highest scores. All right, that's what this cluster is telling us. It's saying that this section here between 4 and 6 is going to be the leading to the highest scores. That's where the cluster is. And if it was down, again, you could show this cluster here, right, is if you're studying less than 3 hours, you're probably going to have lower scores. So that's just some ways of describing parts of the graph. Clusters describe little parts, okay? Sometimes your data just has gaps in it. And maybe there's just no data for that section. So you can see here between 3 and 5 minute eruptions, there's really not any data that tells us how long until the next one's going to happen. But at a 2-minute eruption, there isn't. At a 5-minute eruption, there's a lot of data. So that's just called a data gap. And that gives us problems too, because it doesn't let us make good correlations because this gap is preventing that. Okay. And we don't really have a really good cluster here. I mean, we have a cluster at 2 minutes. So there's a lot of 2-minute duration geysers and a lot of 5-minute ones. But that just doesn't show a lot for like 3, 4, 1, and 6-minute ones. So it's hard to really make substance of what's happening there. Other than you can say that if it goes for 2 minutes or 5 minutes, you can expect that another eruption's coming. All right, so that basically shows the beginnings of scatter plots here. So really the biggest thing that you want to take away from this is that you want to just be able to spot those trends, whether it be a positive trend like you see here with a big cluster at the top, or no correlation here, or a negative correlation here where you see that as you're going forward with some data that your other data is decreasing. That gives you your negative. And you can also have these positive ones where as you're increasing, you're also seeing an increase in your other variable. All right, so that is the introduction to scatter plots. Make sure you get on your Google Classroom and work on that assignment.